Okay, so I've got my basic OSPF implementation. Now I need to verify it. And there are a number of commands you can use to do this, depending on what you're trying to learn. Um, I've actually got all of them up here on the screen, sort of a laundry list of things to try. So I actually started with the routing table itself. Let's go. So show IP route. Um, Now, the IP routing table output doesn't tell you much if you don't know if you don't have some reasonable expectation of what you should see. The reason I was able to look at the routing table before and realize that it wasn't quite right. Of course, I looked at my neighbor adjacencies. I knew that I should have had full adjacency across all links. And the fact that router 2 and router 3 didn't have one was a big red flag. One of the other things that told me that things were not quite right is that scrolling back up here on router 2, um, I noticed that I had an indirect route, shall we say, from 192.168.2.0 to 192.168.3.0. This 128, that was too high. I should have seen a 65 for a direct path out this exit interface here and this exit interface here, instead of an indirect path going all the way around the mulberry bush, as it were. So you need to know what you should see, or your show commands won't tell you. They will tell you what you need to know, but you won't recognize it if you don't have some expectation of how the topology should behave before you start anything. The other thing, of course, the thing that was, as I said, my big red flag was my show IP OSPF neighbor. Let me do that on router 1. Now, I see 23.1 and 23.2. That's a little confusing because I would have expected to see something a little bit lower, or rather, I wasn't thinking quite clearly enough about this. The router ID that OSPF picks, there's an order of precedence to it. We'll work with this in just a minute. It will choose a stated router ID first. Then a loopback address, the highest loopback address available if there is one, and then finally the highest available physical IPv4 address. This is true for both OSPF v2 and OSPF v3, because even with OSPF v3, which is OSPF for providing support for IPv6, the router ID. Okay, the thing to remember here is that the router ID looks like an IP address. It is a 32-bit number in dotted decimal notation. It looks like an IP address. It isn't actually one. It can use an IP address, like, for example, a physical interface or a loopback, but honestly, those aren't the best choice. It is always best to state your router ID directly, purposefully, so you know which router you're talking to. For example, this example right here, 23.1 and 23.2. If I didn't know off the top of my head that 23.1 is router 2 and 23.2 is router 3, I might look at this and not be entirely certain which one I'm dealing with. Now, there are more clues here. My 12.2, that's obviously router 2. My 13.2, that's router 3. So there are some contextual clues here. But really and truly, if you're trying to troubleshoot a major issue under a time crunch, don't force yourself to waste time working out the contextual clues and the circumstantial evidence. State everything explicitly so you can look at the output of your show IP OSPF neighbor and realize, okay, I'm talking to router 1, but not router 2, or router 2, but not router 1, whatever the case. Or in this case, I am router 1. I would be talking, if I would know right off the bat, okay, I could talk to router 3, but not to router 2. That allows me to shrink the domain of my problem to shrink the number of questions I'm asking and where I'm asking them, it speeds up the whole troubleshooting process. Remember, the thing you're looking for when you're troubleshooting is to be able to describe the problem. Once you describe the problem, the solution to that problem may become self-evident. But if you don't know what the problem is, all the things you try are just shots in the dark. For some kinds of troubleshooting, what we call shotgun debugging, which is to say doing a preemptive replacement of field replaceable parts that might wear out anyway. If you're shotgun debugging that way, that might be shotgun debugging by way of preventative maintenance, and hooray, along the way the problem solved itself. But really and truly, until you know how and why you solved the problem, even if you've restored functionality, even if you've worked around, you haven't actually solved the problem because you don't know how to fix it next time. You'll be back at square one next time, just kind of trying things. So always, always, always look for why the problem arose and how you can change it, etc. So next one, IP protocols is another good one. So let's look at IP protocols. IP protocols, for example, let's do let's go Cisco. No, Cisco. Oh, darn it. Show IP protocols will also tell you some important information. Who are you talking to? And what administrative distance are they using? So that administrative distance of 110, that tells me this is OSPF. My routing protocol is OSPF1. That's my process ID. I have a router ID. I see a maximum path. I see the routers, the areas, the networks I'm routing for. Say, for example, if I had accidentally included a network on this list that wasn't physically attached to my device, that wouldn't do me any good, because it will. You have to include the networks which are on the device and none which aren't. You might be tempted to put a network statement for every router, for every subnet on the topology in every router. That is inexact and overkill, because it will only use the ones it is actually participating in. I also see my areas, area 000. I see my masks, so I can look at my subnet, my inverse masks, and my addressing table and make sure everything is right there. That's what I goofed a minute ago, because I stated one of these networks as a /24 when I should have done a /30. I see the last update, and let's see, IP OSPF. Let's try OSPF. So, show IP OSPF will show me external LSAs. It shows me this is a backbone area. If this is an ABR or an ASBR, it will show up here. It will show me the number of times the algorithm has run. In other words, the number of times it has converged to the network. Let's see. Let's do OSPF interface. Let's do OSPF interface brief first. So you can use all of these commands. Oh, no, not that. You can use all. Okay, yeah. Okay. Did I misspell brief? Show IP OSPF interface. So this will show me what my interfaces are doing. I can see what my gig 0 interface is in a DR state. It's in it's the designated router because it's the only router that it's talking to. We'll talk about this more in the last lab for module 10. For chapter 10. When you've got 3 routers in a multi-access Ethernet network, then the DR election suddenly makes sense. Let's see. So I see my serial lines. They're in a point-to-point state, point-to-point type. I see their cost. I see their process ID, their router ID, etc. Now let's see why it doesn't like the brief keyword. Okay. So show IP OSPF interface brief it will work on physical hardware, but it doesn't actually work on in packet tracer, unfortunately. There are some commands in these in these labs which, because they're designed for a physical implementation, may not quite work in Packet Tracer. If you punch something in and it looks right and it doesn't work, try to use your question mark operator or keyword to see what Packet Tracer will allow you to do. Another very fun tool that Packet Tracer doesn't simulate correctly is show run interface. It just doesn't work. But what you can do is show run pipe begin interface, and you'll at least start with the interfaces. So I know that my routers have converged. What I can do now is start tinkering with them. That is actually this will be, let me go up in the instructions. Part 4. We start tinkering with passive interfaces and things like that. Yeah. So part 4 is to configure passive interfaces. So I will go back to router 1. Router 1 needs a passive interface on gig 00. So if I do show IP OSPF int G0 hack 0, I see that is up. It is a broadcast network. Here's the thing. You don't need this information leaking into your access layer. So what you can do is go back into the router OSPF 1, and do passive interface, interface, gig 00. Boom. Now, this doesn't change the network topology at all. It is still going to advertise gig 00 because that network statement is there. It's just not going to use it, going to include it in its LSA broadcasts or anything like that. So now let's do interface again. So the state is now waiting because I set it passive. And if I do show IP protocols now, I will see that here as well. Passive interfaces gig 00. As you're troubleshooting things like neighbor adjacency and routing table updates and things like that, pay close attention to the passive interfaces section, because you might say, for example, if you do passive interface default, which I think we're about to do on a different router, what you'll do is you'll silence everything, and that will break neighbor adjacency with the adjoining or neighboring routers. You don't want to do that unless, say for example, you've got a router off on a corner that it does need to talk to other routers about dynamic routing, but it's only got one link and a whole bunch of Ethernet of gigabit links going down into the access layer. You might set passive interface default there, and then a no passive interface on the one interface that needs to participate in the OSPF routing domain. Hold on. Okay, so now I've confirmed that I can still see my 1.0 network on the other routers. I looked at their routing tables, and now I'm going to break everything. Passive interface default. That silences gig serial 000 and serial 001 on router 1 here. So it breaks those neighbor adjacencies. That's not what I wanted to do. So what I need to do is look at the statuses of, let me look at the statuses of these networks. Let me do serial 0 hack 0. Boom. And it's passive. No hellos in transit. That's a problem. Oh, as I can see, I checked my passive interfaces. I even looked at my routing table, and suddenly I don't have any OSPF routes. It's not what I wanted to do. So let me turn this back on. No passive interface 0000. If I give it a minute, it will regenerate. Give it a few seconds, it will regenerate that. Okay, good. So I have a neighbor. And now if I do this, if I do show IP route again, notice I can talk to the other routers, but I'm going the long way around. Now, the next thing is to do this for router, let's see, do it no passive interface on gig 01, sorry, serial 001. That will regenerate that neighbor relationship, and things will converge. There.